today we're going to talk about operations with exact values. Go through your list, see if you can write down your ordered pairs for all these, and if anybody wants to come up and do that.
I'll do it
if you have a right. Alright, I'm going to write about it. Again, if you guys do not know your ordered pairs, right, I cannot stress to you how important they are to memorize. You can't do anything with exact values if you don't know them. And memorizing is on you guys. You guys are just going to have to do flashcards. I can't really help you with the memorizing process. Yeah. Super. Thanks, Dad. Alright. How did you guys do better than yesterday with remembering?
Yeah.
Good. Alright. What about quadrant? In quadrant 1, what's positive? All. Good. What about 2? 9. What about 3? Good. And then cosine. Awesome. Right. Remember your ASTC. Alright. So what we're going to do today, guys.
What?
Yeah,
I was going to the acronym.
Okay. Oh. Alright, now I know where. I understand. Okay, so what we're going to do is finding the exact value of, maybe when we're doing some type of operation with our trig functions, like adding, subtracting, multiplying, or dividing. So what we're going to do first is we're going to find the exact value for each of these trig functions individually. Okay, so what I'm going to do is figure out what is the sine of 225? What's the tangent of 45? Just individually what we did yesterday. So if you are someone who is okay with drawing your picture, right, we can figure out the 225. You want to make your little ASTC. Right, figure out where the 225 is. And here's your 180, 90, 0, 360, 70. And so let's see, 225. We're going to be somewhere in here. So the first thing we can think of, if we're dealing with our sine of 225 and we're in the t quadrant, positive or negative? Negative, good. Because only tangent is positive here. So if we're talking about sine, we know it's going to be negative. So the next step is to figure out our reference angle. So the reference angle is the distance back to that x-axis. So how many degree measure is between 225 and 180? Oh, fantastic. So what we're going to do really is the negative sine of 45. Does anybody know your 45 degree ordered pair? Good, negative radical 2, awesome. Perfect. Are you guys okay with just going right to that radical 2 now? We kind of get that word too? So if you need to look up at the top, right, remember your cosine is the first one and sine is the second. So if we're talking about the sine, it's radical 2 over 2. Just bring down your negative. All right, now we're adding. Oh, tangent of 45, this is a nice one. You guys have 1, nice, Rita. How did you get 1 so quickly?
Because the sine and the cosine of 45 are the same.
Good. Yes, you're doing the sine over the cosine, and they're both radical 2. Radical 2 over 2 divided by radical 2 over 2. So something divided by itself is always 1. And that one comes up a lot. Tan 45, you might just want to know it's going to be 1 all the time. Alright, so once we figure out each of these individually, now we actually have to, let's see, we got our positive, negative, that looks good. Alright, so now we have to follow our rules for fractions. What we have is a negative radical 2 over 2 plus a 1. Right? When we are here, we're adding fractions, right? Adding or subtracting, make sure we remember we need to get a common denominator. So let's put this thing over 1. What would you guys multiply by? 2. 9. Okay, so multiply both sides by 2. Now, once we have a common denominator, we're going to take the tops and add them together. But are these like terms, a negative radical 2 and a 2? No. So when you combine them, the only thing you do is kind of group them together. Negative radical 2 plus 2 all over 2. And that's it. We can't do our little heart method of canceling because we don't have anything in front of the radical 2. If there was like a 4 there or another 2, you could. right? But this is it. So sometimes if you guys have separate things, you know, it's okay. All right. So let's try to find the exact values. Why don't you guys try to find the exact value of the cosine 120 and the sine 30. See if you can get that far. And then we'll talk about if you feel like you could do the whole thing, even better. A lot of this is just kind of re-practicing your ordered pairs.
They were. You can still see the heart's already there. Yeah, if you feel mine, mine looks really big. This one you can't see like this. This one's very close. What, the other second hole? No, that's the first one. Oh, yeah, and the other one is bigger. Yeah, but you can feel the second one on mine. You can feel this. Yeah, I think it's twice as mine.
All right, so for the exact value, I hope we got negative 1/2 here, right? Minus the 1/2. If you guys, for your cosine of 120, okay, make sure your 120 is over here. We got our ASTC, right? The negative sign is because you're in the S quadrant talking about cosine, so make sure you don't forget that. And just watch which axis you're going back to, right? Make sure we're always going to the X axis for your reference angle. So you were really using a reference angle of 60. So from that, you can look up to find our 60-degree ordered pair. The cosine of 60 is at 1/2. We make it negative. And then when we want the sine of 30, right, we're just looking at the sine at the 30-degree, which is also 1/2. Okay, just watch your signs. And when you subtracted those, what did you guys get? Good, -2 or 2, which is really just what?
Negative 1.
Negative 1, perfect. Okay, you won't see -2 over 2 as an option. It's always going to reduce it. All right, let's try another one. This time, what operation are you doing? Perfect. So we're doing top, top, bottom, bottom with our rules. Okay. So go through, find the exact values on each individually. If anybody wants to come up and do it up here, feel free. Oh no, sorry. We actually really like doing this kind of stuff on like friction questions.
Yeah, it's supposed to be tougher on that one, but then she says no good.
You are, do you think you got it? I'll combine and check it out.
Question mark. So when you multiply this negative radical times the radical 2.
So if you multiply, you just multiply what's inside the radical. So it's like a negative radical. Perfect. Multiply top, top, bottom, bottom. No, you gotta go down. Add it one down. Right, so in here we have to do what about right? You can't find the negative off. Oh, okay, so you're negative 2 times what we should be going on. Perfect. Oh, no, okay. This only causes the direction. Okay. So since you're in the sign, you're still going to be negative. Good question. Good, right? So which one do you Oh, fantastic. Nice job, Katie. Thank you. This was good. Just make sure you guys are remembering your negatives. Top, top, bottom, bottom for your multiplication. Looks great. How was this one for most of you?
Good.
Good. I saw we did a good job with this stuff. Some of you just didn't know how to multiply. When you guys are multiplying your radicals, just multiply what's underneath the radical. Right. Together, and that's it. Right. If you could reduce what's under there, we want to reduce it, but we don't have a perfect square that looks in this way. Okay. All right, let's flip it. Who's got the next one? You want to do it up here? And some of you guys are flying through. If you want to, you can just keep going. This is well, all right. Go ahead. Come on down. If you want to use smart sleep, you can do that too. Okay. Now, once you're here, you don't want to leave the radical.
No. Not there. I'm pretty sure it's not.
I think it's your sign. Oh, yeah, I think the sign is radical. Yeah.
I got that right there. It is.
Yeah, I'm sorry. You have great work though with oh, okay. Yep, there you go. Good. Perfect.
Times by the radical 2. Times the radical. Oh, it's still radical. Yeah, 3. You got it, dude. I believe in you. The radical by 2. It's probably 6. Look at the tip is radical. Oh, what happened to it? Yeah.
No, because you're at 180.
Oh, really? I used to go.
Lovely. This is so good. Good job. I love the copy change flip that happened. This is a really good thing. A lot of you guys left maybe like radical 3 over radical 2. And Julia rationalized the denominator by multiplying the top and the bottom by radical 2. So that was fantastic. Got radical 6. And then when we multiply the radical by itself, it goes away. It's just radical 2. Super. Any takers for 5? You want me to check it first?
No, I'm good.
Yeah, someone do the smart slate if you want.
Hey, I got it.
Who said they got it?
I think maybe. Hopefully.
Go for it, Carly. You can go up there.
Oh, do I have to show my work?
Yeah, it's -1. So like you're going, here's your -180 and seeing it's +180. So you're going here, it's -1, 0, -1. Yeah, so now get your common denominator there. Ready?
Are we supposed to do the next one then?
Good job, I love it. Top, bottom looks good. Yeah, go on to the next one. You guys got this one? Go on. Like again, the Regents love this stuff where you guys are finding values because they like things where you have to remember your ordered pairs. There's a lot of work in here, and then you actually need to know how to multiply fractions or rationalize. So this looks great. Actually, you know what? One time do this one with you guys. What has to be negative? Yeah, the negative numbers are kind of messing you guys up a little bit. So I just want to do this one with you guys because we've had a lot of questions with these negatives. Alright, I'm going to draw a picture. This is kind of good review for our coterminal. Now, if we have -240, right, here's your 0, 360, 90, 180, 270, right? So -240, we have to go down. Now, this part, guys, does not affect whether your fraction is positive or negative. It just tells you the direction. That's what I've had a lot of questions about. So because it's -240, we're going to go down direction about 240 degrees. So we should be somewhere in quadrant 2. Okay. Now, we want to look, we have cosine. Is cosine going to be positive or negative here? Good. So we definitely have a negative cosine of something. Carly, how do you know 60?
Because we get back to the x-axis.
We're going to get back to the x-axis. Well, this is -240, but if this is hard for you guys dealing with negative, do you guys remember coterminal? What was the same thing as a -240? Good, +120. Nice. Remember how they had to make 360? Make a whole circle? So you could also think about it this way, that there was going to be 60 degrees between there. That's great. So, yeah, that should work too. I don't know. Yeah, I guess that would work. So if you took your 60 degree, what's your cosine at 60? -1/2. Good. Now the tangent of 225. Okay, well 225 is going to be in here. Oh, we're in the T quadrant too, so tan positive or negative? Positive, because we're going to keep our little positive. Yeah, good. Positive tan 45. And tan 45, I told you guys, it's easy. It comes out just 1. Okay. So from here, we got to make our common denominator. Because we're adding, so we have -1 plus 2 is going to be 1, and we keep our bottom the same. So it should be a +1/2. How was that for you guys? So, all right. Let's try the last one. Okay, be careful with that negative. Remember, it only affects the direction you're moving. It does not affect if your fraction is positive or negative. You still got to look at what quadrant you fall into for that. I'll pass on your homework.
So,
anybody want to put it up? That's fine. I debated going on to like reciprocal trig functions, and I like you guys go my other classes because I work so much. So I'd rather more people know this stuff. It's like really
yeah, but suppose where would I go? Oh, you could add the 180 and then oh wait, what? I know. Or do you just give the 180? Okay, but what do we have to have? Oh, okay, I got you. I got you, John. What? Yeah, use terra.
Anybody ready to smart play or come up?
Nah.
Nah.
It was Juliet, I thought.
Perfect. Okay, sorry, you got it on the wrong side.
That interrupter was cool. Wait, is this one? Oh, yeah, like 13 seconds. Cool. Hey, I'll just You're laughing really good. No. What's that? Because you can't combine those. Oh, you did the wrong form of 16. Gotcha.
Right, so your cosine is how your
But that'd be negative.
Okay, and you said what did you say? We're really doing the negative sign. It's just like anything else. Keep your sign though in there, so it's not six figure out, so that actually figure out what we're here. Or do you know your sign?
Negative 1. Oh, hold on.
That's true.
There you go. The other thing is negative one, you actually have like take that down. Oh, it's one. When you're on one of these special ones, this is where you'll get your order here. You think, how did you move? You went left one, and how you're looking at that. So you're going over here, you're like negative one, and then you're not moving at all. Good, so that's just your walk up. Now which one is that cosine? Good, so you just then take it. There you go, good. Now you're going to have a denominator. So it's like that's the hard part. I always draw stuff out because like looks great. Good job. So make sure negative 180. Good job. You're going down here. Negative 180 is the same exact thing as positive 180, right? When you're at those special quadrantal angles, make sure you're thinking your radius is 1 from that unit circle, so we're going left 1, left is negative, and then you're not moving up or down, so negative 1, 0. Since you wanted the cosine is your first coordinate, which is just negative 1, so that's why you have the negative 1 here. You really did a great job. Common denominator. You look fantastic. Super. Okay. All right, so your homework today is that worksheet.